Good day, students. My name is Darlington. We shall be discussing the concept of salt in chemistry. Now, what is salt? A very simple definition. Salt is said to be formed when all the hydrogen ion in an acid is completely or partially replaced by a metallic or ammonium ion. Now, that is the definition of salt. We now look at categories of salts. I shall revisit and, of course, give a componential analysis of the definition of salt under these categories or types of what? Salt. Now, the first one is normal what? Normal salt. Now, it will intrigue you to realize that the definition of salt is completely that of a normal what? Salt. So which means our definition of, our understanding of the definition of salt will be pivoted on your understanding of normal salt, which I'm about to explain. Now, what is normal salt? A normal salt is said to be formed when the ionizable hydrogen ion in an acid is completely replaced by a metallic ion or ammonium ion. Normal salt, note that normal salt is formed by monoprotic or monobasic acid only. Monobasic or monoprotic acid, that is a simple rule you must know. A simple rule, a snippet you must bear in mind. All normal salt is formed by monobasic or monoprotic acid, as exemplified in the equation of reaction below. This is sodium plus hydrochloric acid, a monoprotic acid. What is monoprotic? When I say monoprotic, proticity, as we have learned in the preceding lesson on acid, means the number of hydrogen ion which one molecule of an acid will relinquish or liberate in water. That is the number of hydrogen ion. For example, HCl has one hydrogen ion, which means in water it will liberate only that one. So in that case, it is regarded as a what? A monobasic acid or a monoprotic acid. So all monoprotic acid form normal salt. So this will give you sodium chloride, the normal salt, and what? Hydrogen what? Gas. Then this is calcium plus HNO what? HNO3. Calcium nitrate plus what? Water and what? Nitrogen 4 oxide. So in that case, if you look at this reaction, you can see this is a normal salt, this is a normal salt. However, few normal salts are neutral. Others are acidic or alkaline. It's just few normal salts are neutral, while others are acidic or alkaline. Now the question is, the searching question you might be asking is, how do we know if a normal salt is acidic or what alkaline? That is, if it turns blue, it must be red, or red, it must be blue. How? Now, the simple golden rule or nifty rule you must bear in mind is that when a salt dissolves in water, I'm going to exemplify that right now. When a salt dissolves in water, if it furnished a strong acid and a weak alkaline, such a normal salt will turn blue litmus red. That is, it will behave characteristically as an acid. On the other hand, or in contrast, when a normal salt dissolves in water, if it furnished or produced a strong alkaline and a weak acid, then such a normal salt will turn red litmus paper blue. That is, it will behave typically as an alkaline. Okay, for example, sodium tricarbonate 4. Look at a simple way you can do this. Plus HOH. Some students might be thrown into upheaval and confusion. Now, what is HOH? Please, HOH is what? Water. But I want you to have a glimpse of the transition of ion. So that's the reason I'm writing water as what? HOH. So that you can glimpse the movement, the actual movement of the what? Ion. Now look at this. Sodium, of course, will be attached to what? Hydroxide ion. So this will give you 2 sodium hydroxide ion. Now this man, tricarbonate 4 ion, will be attached to these 2 hydrogen ion. Of course, to yield tricarbonate 4 what? Acid. Please ensure that the equation is balanced. Sodium 2, carbon 1, carbon here 1, oxygen 3, oxygen here is 3 plus 2 here 5, oxygen 3 plus 2 here 5. So this is strong alkaline, and this is what? Weak what? Weak acid. From this illustration on the board, we could deduce that sodium carbonate will turn or develop red litmus, what? It will develop or turn red litmus blue, indicative of the fact that it is a what? An alkaline normal salt. Why? Why? Based on the nifty rule. The nifty rule says that when a normal salt dissolves in water and furnishes strong alkaline and weak acid, then it tends to behave as a what? A strong alkaline. Which means that the solution will contain predominantly hydroxide ion and then a meager amount of hydrogen ion, since the acid is weak, and you know what is weak acid. Now, so this is strong alkaline, therefore this man will behave characteristically as an alkaline. So this man is a normal salt, yet it turns or develops red litmus blue. Then another example I would like to give you sodium chloride plus HOH, sodium hydroxide plus HCl, strong alkaline, strong acid. You can see both medium and strong. So which means the solution will contain essentially equivalent or commensurating amount of hydroxide ion and hydrogen ion. Since both are strong alkaline and strong acid, strong alkaline and strong acid respectively. Therefore it will neutralize, making sodium chloride a neutral salt. Do you understand? The same thing with potassium what? Chloride. Potassium chloride in water too will give you potassium hydroxide and sodium what? Hydroxide. Potassium hydroxide and what? Hydrochloric what? Acid. Now some students always ask a question, does it mean that sodium chloride is the only edible salt in the world of chemistry? Yes. Sodium chloride is the only edible salt. Yes. Sodium chloride is not the only edible salt, please. For patients that have high blood pressure, that is high systolic blood pressure, it is recommended medically to consume potassium chloride. So patients with high systolic blood pressure, that is hypertensive patients, are always advised not to consume sodium chloride. Do you understand? Why? Because the presence of sodium ion in the blood plasma will skyrocket a condition known as arrhythmia, which is a medical condition associated with abnormal beating of the heart. So to discourage the medical condition of arrhythmia of the heart, then patients are advised or recommended that they consume potassium what? Chloride. Of course, it's a neutral salt as evident in the equation of reaction. Strong alkaline, strong acid. So this is a neutral salt. Now, that is for normal salt. So if you look at our definition of salt, we say a salt is said to be formed when the ionizable hydrogen ion and acid is completely or partially replaced by a metallic or ammonium ion. So you can see that word, completely replaced. That's for normal salt. Okay, now look at the second category of salt we have. The second category of salt we have is acid salt. Acid salts are generally formed by polyprotic acid. What do you mean by polyprotic acid? Poly means many, and it embodies or incorporates such acid as diprotic acid like tetraoxophosic acid or sulfuric acid. Then we have what is known as triprotic acid, e.g. phosphoric acid or tetraoxophosphate 5 acid, H3PO4. So acid salts are formed by polyprotic acid, and it occurs when the ionizable hydrogen ion or proton in an acid is partially replaced by a what? By a metallic ion. For instance, I'm going to use the manufacture of sodium sulfate or glauber salt, sodium tetraoxophosphate 6, as an illustrative example. Now look at this. Here we have got to be sulfuric acid or tetraoxophosic acid. Recalling that polyprotic acid yield acid salt, monoprotic acid yield normal salt. So this is an archetype of a polyprotic acid. I told you polyprotic embodies di, tri, and tetra, and so on. So this is a diprotic acid combining with what? combining with sodium what? Chloride. You understand? We call this the salt cake method in the industrial manufacture of glauber salt, that is sodium tetraoxide 6. Now in this reaction here, we have 2 hydrogen ions, but here we have 1 sodium ion available to replace the 2 hydrogen ions. Of course, there's no such thing as rocket science or brain surgery in chemistry. It is exactly what is available that participates in the reaction. So since we have 2 hydrogen ions and 1 sodium ion, so 1 sodium could only replace 1 of the hydrogen. So this will give you sodium hydrogen tetraoxide 6, or old name sodium bisulfate, and the remainder or the residual hydrogen ion associated with the chloride ion to give you hydrogen chloride. Now from this illustration, I could reiterate the definition of acid salt. As acid salt is said to be formed when the hydrogen ion, when all the ionizable proton or hydrogen ion in an acid, in a polyprotic acid, use that word polyprotic acid. When an acid salt is said to be formed when all the ionizable hydrogen ion or proton in a polyprotic acid is partially replaced by a metallic what? Ion. So that will give you this. Note that an acid salt still retains or reserve acidic properties in that it could develop a blue litmus paper red, that is, it could turn a blue litmus paper red, and as well as react with what? Alkaline to form salt and water. However, the only exception to that fact, is sodium hydrogen triacylcarbonate 4. Students and even teachers normally make this mistake of regarding sodium bicarbonate or sodium hydrogen 4 as an acid salt. And when you ask them, they will quickly adduce the reason that an acid salt is recognized by the presence of a hydrogen ion between the acid radical, in this case triacylcarbonate 4, here tetraoxide 6, and the metallic ion, in this case sodium and sodium here. But the only exception is sodium bicarbonate. And some students normally ask the searching question, that's why. But this man is supposed to be an acid salt because of the hydrogen ion here. But please do not be tempted. Sodium carbonate is the only compound that is barred from the rule that an acid salt contains hydrogen ion between the acid radical and the metallic ion. Now the question you are supposed to ask is why. The reason is that according to a result of experiment, when sodium bicarbonate or trona or sodium hydrogen triacylcarbonate 4 dissolves in water, it tends to furnish strong alkaline medium and a weak acidic medium. As a consequence, it is regarded as what? An alkaline salt, not a basic salt. Take note of that. So this is the only exception, the only barring exception from acid what? Salt. So however, or by extension, an acid salt tends to convert or translate into a normal salt, giving excess supply of the metallic what? Ion. That is, an acid salt will translate as exemplified in the equation of reaction on the board, plus sodium chloride. Now we have 1 hydrogen ion and 1 sodium ion available to replace it. Therefore, we have actually Na2, SO what? SO4. Then the hydrogen combined with this chlorine to give you hydrogen chloride. So you can see that this acid salt has translated into what? A normal salt. Then we have the third category. Which is called basic salt. The third one is called basic what? Salt. What is a basic salt? Basic salt, recall, normal salt is formed by monoprotic acid. Acid salt is formed by polyprotic acid. Basic salt is formed by polyacid alkaline or polyacid base. And of course, recall to the preceding section or preceding lesson on base, you will realize what is acidity of a base or hydrosity of a base. So a basic salt tends to be formed by polyacid alkaline, in that it occurs or is obtained when the hydroxide ion available in a given molecule of an alkaline is partially replaced by the anion of an acid. Example of polyacid alkaline or polyhydroxic alkaline. Let's use zinc hydroxide. This is a dihydroxic alkaline or diacid base. Now zinc plus what? HCl. I told you that a basic salt is said to be formed by polyacid alkaline or polyhydroxic alkaline, in that it is secured or obtained by treating an alkaline with an acid when the number of hydroxide ion in the alkaline is partially replaced by the anion in the acid. So here we have 2 hydroxide ion, while we have 1 chloride ion for the acid. So in that case, this will give you zinc hydroxide what? Zinc hydroxide chloride. Zinc hydroxide chloride plus the OH, the one OH combined with this H to give you water. Then we also have another one here again, which is, we take another example, which is, this is a typical example. Now, for zinc hydroxide chloride, a basic salt can readily be identified by the presence of a hydroxide species, between the metallic ion and the acid ion. So in that case, zinc hydroxide chloride, how do we know if this is an alkaline? We shall examine this question from UTME position. How do you know this is an alkaline? The presence of OH between this and this indicates that this is what? An alkaline, and a basic salt. Now a basic salt still reserves basic characteristics. This means that it would develop a red litmus, that is, it will turn a red litmus to what? Blue, as well as neutralizing acid to form salt and water. By extension, a basic salt would readily translate into a normal salt on supply of excess of the acid, as given or delineated in the equation of reaction below. Now, this is zinc hydroxide chloride. Zinc hydroxide chloride plus excess of this. This is excess, in excess of HCl. So we have 1 OH. This will completely replace this to give you zinc chloride and water. So this is a normal salt. This basic salt has translated into a normal salt, and they are formed by a polyacidic alkaline. Then the next one is double salt. The fourth is double what? Salt. What is double salt? A double salt is said to be formed when an equimolar aqueous mixture of 2 simple salts are dissolved in water and subsequently submitted to crystallization. That is, when I say equimolar mixture means an equivalent amount of the 2 simple salts dissolved in water, then allowed to crystallize. Example of double salt. Now, to form double salt, of course, in external exams like WAEC SSC, WAEC PC, or even in UTME or POST-UTME, you might be given an example of a double salt, and this always poses stand difficulty to students in terms of recognition. But how do you recognize a double salt? There is a simple rule or formula I will give you, and that is the simple formula I've been using. Now, this is the formula to develop an example of a double salt. This is it. Tetraoxosulfate 6 ion, old name, sulfate of group 1A plus tetraoxosulfate 6 ion of trivalent element plus 24 molecules of water of what? Crystallization. Of water of crystallization equal to what? Double salt. This is a simple formula. So which means tetraoxosulfate 6 of group 1 integrating with tetraoxosulfate 6 of the trivalent beta plus 24 molecules of water of crystallization. That will give you what? A double salt. And that, of course, explicates our definition of double salt. That is, a double salt is said to be formed when an equimolar or equivalent amount of 2 simple salts, e.g. sulfate of group 1, sulfate of trivalent beta, is dissolved in water and then submitted to crystallization, which is when submitted to crystallization, they tend to crystallize out with 24 molecules of water of what? Hydration or water of crystallization. So example, gratia. So what we have here, tetrodosis of group 1. So you can use any example. Sodium tetraoxosulfate 6 plus tetraoxosulfate 6 of trivalent metal, of trivalent element. We have here to be what? Aluminium tetraoxosulfate what? 6 plus 24 molecules of water of hydration or water of crystallization. Now what we have now, fusing all the compounds together, we have here to be 2 sodium, we have 2 aluminium, open bracket, sulfate here is 3 plus 1 here 4. So in parentheses, sulfate written in parentheses and the subscript written below and to the right of the parentheses, dots 24 what? Water. Now this can be abridged as divide all through by what? Divide all through by 2. If you divide this man by 2, divide everything here by 2. So 2 divided 2, we have just one sodium. 2 divided 3 here, we have just 1 aluminium. 2 divided 4 here, we have it to be SO4 2. Then 2 divided 24, we have it to be what? 12H2 what? O. In the textbook, this is the example given, but this is the formula from which those authors derive the example. And of course, in your POST-UTME, it will be given as this. So this is written as, this is articulated as sodium aluminium tetraoxosulfate 6 dodecahydrate. This is an example of a double salt. Then for a complex salt, a complex salt is one that contains complex ion, that is a ligand or a donor and an acceptor. In that case, the acceptor is always a transition metal which has a vacant what? Orbital, which has a vacant orbital to accept electron pairs, while the donor is always an electron-rich substance that can relinquish or give off its what? Electron what? Pairs. Examples of complex salt include copper, tetraamine copper 2 ion, tetraamine copper 2, tetraamine. This is, now if you look at this is a complex ion. We call this what? A complex what? Ion. I told you that a complex salt is one. We are looking at complex what? Complex salt. A complex salt is one that contains a complex ion, that is a ligand, an acceptor. This is an acceptor. Copper here is an acceptor, meaning it has a vacant orbital. Vacant what? Orbital to accept electron pairs. Then why this amine? Please take note of this. Amine, tetraamine copper 2 ion, tetraamine. Now the amine here should be discriminated from the organic amine, in that the organic amine has only one N. Why the inorganic amine, ammonia here, in coordination compound, ammonia is giving the word amine, water is giving the word aqua. So compounds are given an entirely different name. Of course, that's another facet of chemistry which is beyond the scope of this lesson. So this is amine. Why the amine here in coordination chemistry, briefly, has double what? N, amine. So please note the discrimination between the two amine. This is organic amine incorporating one M. This is amine in coordination chemistry, in coordination compound comprising two M. So this is an acceptor and this is what? A donor. This is a donor. So which is the what? Amine. So the name of this compound is, so these two, the acceptor and the donor, constitute what is known as what? Complex ion. 4 minus 2 will give you what? 2, which is the charge on copper. Copper here is copper 2. So if you have to call the name of this man, you've called it from the amine, from the donor. So this is tetra what? Tetraamine copper what? Copper 2 what? Aeon. Now, how do we now form this? In past question, though they rarely ask question on complex salt in WAEC, but in POST-UTME you'll be given question like this. Now, how do you develop an example of a complex salt? Now, this is it. Copper, tetraamine copper 2 aeon, NH3 4 in parentheses. Remember, this in square bracket 2 plus, and chloride aeon here, this chloride aeon. So when they interchange the valency or interswitch their valency, so this is 2 here, this place is what? This is 1 here, y here is what? 2. So this will give you this NH3 in parentheses 4 Cl2. So this is tetraamine copper 2 chloride. So tetraamine copper 2 chloride is a what? Is a complex salt. Now let me give you a resume of what? Complex salt. Tetraamine copper 2 aeon is a complex salt. Diamine silver 1 aeon, diamine silver 1 what? Aeon is a complex aeon. Then diamine tetraamine copper cadmium 2 aeon. Tetraamine cadmium 2 aeon. This is as well a complex aeon. Tetraamine cadmium 2 aeon. Then tetraamine zinc 2 aeon. Tetraamine zinc 2 aeon. This is a what? This is a complex salt. Then we have ferrosulfuric aeon. Ferrosulfuric aeon. How do you derive that one? All these are examples. So you can create your own example from here. So in case you see this in past question, these are just the complete example. We are left with just 2. I'm going to give you that and to derive it and articulate it differently. So once you are giving something like this, all you just need to do, look at the aeon, the anion. If this is, for example, you are required to write diamine tetraoxosulfate 6. Diamine tetraoxosulfate, that's a complex compound. Of course, beyond our scope of chemistry. But this is a simple rule to know some coordination compound. Now, diamine silver 1 aeon, please look at it very well. Diamine, this is diamine silver 1 aeon. So you now write tetraoxosulfate 6. So when you write it, so they will interswitch their valency. So 2 here, 1 here. So when you write this now become Ag, NH3, close the bracket. Remember, this is applying to this 2 is applying to every one of them. So this is going to be like this. 2, then SO what? SO what? SO4. So this is diamine silver 1 tetraoxosulfate 6. Diamine silver 1 tetraoxosulfate what? 6. Now another example is ferrosulfuric aeon, that is hexacyanoferrate what? Hexacyanoferrate 3. Now this is FeCN6. Now if here is 4 plus, look at this. If here is 4 minus, that means 6 minus 4 will give you what? Minus 2. Look at this. 6 minus 4 will give you what? 6 minus 4 will give you what? 2. Which means that the charge on the ion here is what? 2 plus. So how do we call this? This is going to be hexacyanoferrate what? 2 what? Aeon. Hexacyanoferrate 2 aeon. Now this last one is Cn close bracket 6, then in square bracket 3 minus. Now when you have the 6 minus 3, 6 minus 3 will give you what? 3. Which means the charge on the ion here is what? 3 plus. So this is going to be hexacyanoferric 3 what? Aeon. Hexacyanoferric 3 what? Aeon. Or aripaplane, which is somehow confusing. For aripaplane, see this man is ferric, it's going to be ferrosulfuric aeon. Now since this man is ion 2 here, it's going to be ferric ferroso ion 2 what? Aeon. Do you understand? So these are examples, a complete and a compendious example of a complex salt at this level of chemistry, whether it's your 100 level or even in POST-UTME and in all external exam at this level.